Test 18 review for Algebra 3. Do we have any questions over number 1? Number 1. Okay. And I don't have a physical copy of it in front of me, but you should. And it says the reflecting surface of a parabolic antenna has the shape formed when the parabola is y equals what? 1 over 16x squared? Is that right? Okay. It's rotated about its axis of symmetry. If the measurements are in feet, how far from the vertex should the receiver be placed if it is to be at the focus? So one of the things you consider is that let's call this a parabolic antenna, and that we want the receiver, okay, to be the focus. Okay, does that make sense? Okay, so it's going to come to about there. Now, our equation whenever our vertex is at 0, 0 is y equals 1 over 4p x squared, where p represents the distance from the vertex to the focus. So p represents that distance right there. P is what they're asking about. So all I have to do in this equation is take 16 and divide it by 4, which is 4. So that antenna, the receiver needs to be 4 feet from the vertex of the antenna. Does that make sense?
Yeah.
And it won't be any harder than that on the actual test. Okay, I mean, I can tell you that you're pretty much, it's going to be a different number, but you're going to end up doing the same thing. All right? All right. Number 2. Number 2 reads, a parabola has its vertex at 2, -1, its focus at 2, 1. Write the equation of the parabola, the directrix, and the axis of symmetry. Graph the parabola. So, all right, let's start off here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. All right, start with that. All right, the next thing it tells me is that its vertex is at 2, -1. I'm still surprised, maybe I'm talking to the wrong crowd here, over people that still can't get coordinates right. They switch their x and their y. Okay, our vertex here was what? 2, -1? 2, -1. All right, that means I'm going to go to the right 2, down 1. All right. Okay. All right, so that's my vertex. Focus is at 2, 1. Okay, so my focus is here. Okay, so which direction is this going to open? It should open towards the focus, right? So I should see something. It's going to look roughly like this. Okay. It says write the equation of the parabola, the directrix, and the axis of symmetry. Okay, let's see. So let's start with the equation of our parabola, which I believe is, give me a second here, it should be y minus k equals 1 over 4p x minus h squared. Okay, that's our formula whenever our vertex is not at the center. So our h and our k are our coordinates 2 and -1. So we would get y plus 1 equals 1 over 4 times the distance from our vertex to our focus, which you'll notice is 2. So 4 times 2, x minus 2 squared. That x minus 2 squared is going to stay put. We won't end up doing anything with that, but we will end up subtracting 1. So my equation of my parabola is 1 over 8 x minus 2 squared minus 1. Okay, and that should make sense to us because that equation should tell us everything that we already know. 1, we know that it's going to go down, my vertex is going to go down 1, right? We know that it's going to go to the right 2. We know that the distance from our vertex to our focus is 2. 8 divided by 2 is 4, which gives us our original equation. So I'm going to kind of slide back here and make sure of this. Let's see. And so our equation is correct. So that's our first part. Okay, the next thing is that they wanted the equation for our directrix. Okay, our directrix should be a horizontal line. Okay, because our parabola is opening up or down. Okay, and it should be the same distance away, but on the opposite side of our vertex as the focus was. So if our focus is 2 away up, we're going to be 2 away down. 1, 2. Let's see. Should be right in there. So our directrix, or dirtex as some people call it sometimes, our dirtex, is it not one of those days? Okay. Will be y equals, I believe, -3. Okay, because a horizontal line is noted as y equals. Does that make sense? Okay, so notice that our focus is 2 above, right? So our directrix has to be 2 below. And because this is opening up, our directrix is always going to be perpendicular to the axis of symmetry. Okay, our axis of symmetry will be, well, let's use a different color. Our axis of symmetry is going to be this line. Okay, it's going to split it. So our AOS is going to be x equals 2. So our directrix is going to be y equals -3. I don't know if I answered your question or not. Did I not? Okay, so do we understand the axis of symmetry part? Okay, so are we struggling with knowing whether or not it is horizontal?
No, I just
You
don't
want?
understand how to get like.
Okay, so I get where you're coming from now. All right, from our vertex to our focus is 2, right? So I had to go up 2, right? So from our vertex to our directrix, we're going to have to go down 2. The vertex is the midpoint between the directrix and the focus. So had our focus been, let's say, up 4, right, we would have had to go down 4, right? So I'm counting, granted, it's not, y equals -2 because it's 2 below the vertex. It's -3 because my vertex is already at -1, so I have to go 2 below that, right, and get that equation. Okay? Does that help?
Yeah.
Okay. And let's see. So for all of that, it wanted, right, the equation of parabola. We did that. Directrix, axis of symmetry, graph the parabola. I believe we've accomplished all the tasks. I want to double check my work. Y equals -3, x equals 2. Yep. I mean, I'm not so concerned with how wide or whatever. I don't need your parabola to be precise. Okay? I need it to open the right direction. I need your focus at the right coordinates. I need your vertex at the right coordinates. I need your axis of symmetry to be the correct line. I need your directrix to be the right line in your equations. There's a lot there. Okay? So I'm not going to care if, I look in the book and, well, actually, that parabola looks more like that. That's not important. Okay? Not here, it isn't. All right, number 3. Number 3, okay? Okay. Anti-log. All right, so again, I think these are maybe easier than you're thinking about them. If this is anti-log 3, base 3, 3, then all I'm doing to find that is taking 3 to the third, which I believe is 27. Okay, so your answer is 27. Your other one, your B, is what? What's base 5, -2. So you're going to do 5 to the -2, which should be what? 1 over 25. Is that correct? All right, and I'm going to check my answer key. 27 and 1/25. Right, but 0.4 isn't 0.4. You'd be looking at. It should be 0.04, not 0.4. Maybe you just wrote it down wrong. Okay, but I'd prefer this be left as a fraction. So did you get the A and just miss the B? Okay. All right, number 4. 4, okay. Dylan, if I were you, I'd probably have at least the document opened up.
Yeah, I got it.
Okay, you got it opened up. And I'd be writing, and if I'm sitting in your position and I don't have anything else, I'm going to have a sheet of paper and I'm going to be trying to work it out. You know what I mean?
Yeah.
Okay. Number 4. Okay. I know how to solve this. I'm just trying to think of the correct terminology for it. We got x plus 1, negative 3, 4, x. Because I have directrix in my head, and that's not what we're doing here. Let me explain what we're doing. You're going to multiply through here, right? Top left to bottom right. You're going to subtract the product of bottom left to top right. So as I write this out, I've got x times x plus 1 minus 4 times negative, well, show that better, I guess, 4 times negative 3.
Oh,
Why am I not thinking of what the terminology is for that? It's determinant. Determinant, thank you. All right, so we're going to distribute the x, so I'm getting x squared plus x. That's going to be negative 12, but I'm subtracting it, so I get positive 12 equals 18. So don't forget that 18 left over there to the right. I would subtract the 18 because I believe what they're asking you to do is solve for x. X squared plus x, that's what, minus 6. All right, so we've got x and x. Let's see. It's probably going to be positive 3 and negative 2. All right, so x equals negative 3 or positive 2. Let's check the answer key here for number 4. Negative 3 or 2. And because we're not dealing with like a log or something like that, or even a natural log, we can accept negatives. Did all that make sense to you? Okay. All right. So this, if you can, I firmly believe that if you can remember to do this right here, that you're going to be fine.
I can do that. I just didn't know where to go there. Like, I didn't know if they wanted me to not FOIL.
Factor.
Factor,
Yeah. Yeah, you want, and I'm trying to see, because it does say in the question, solve for x.
Right.
All right, so that's what you need to be able to do. Okay, number 5. Okay. Number 5, if t varies inversely as y squared. Okay. All right, so let's start off. T equals, right, inversely as y squared, which means y squared is going to go on the bottom directly at m. So we got m on top. Okay. And inversely as the square root of n. Okay, so square root of n goes in the bottom. What happens to t when k is multiplied? We do have to have a constant. Our constant will be up there. Okay. So far, does this part of it make sense? Okay. All right. I'm not a big fan of these questions, and this is probably not one that I would end up doing on a test. But they want to know what happens to t. Notice this, that t equals this. Okay. So what we're going to end up doing eventually is we want to separate all this out from what we're going to change. Okay. What happens to t when y is multiplied by 5? So we would say 5y squared. 5 is multiplied by 5. M is multiplied by 3. So we have 3 mk. Okay? And n is multiplied by 9. So if I've got this right, square root of 9n. Now I'm going to check the answer key to make sure that I'm writing that down correctly. All right, we had km, y squared over that. That looks good. Okay, the only thing, a couple of things I want to do here, put that in parentheses, put this in parentheses, okay, because we're going to square the 5 as well. Okay, everything else here looks good. We're going to simplify what we can simplify. We leave that off. That would be, what, 25 y squared? And that's going to end up being 3 square root of n. All right. Which means this 25 into 3 will multiply to be 75. So that's coming out as 75 y squared radical n. Up here we've got 3 mk. So ultimately what happens is that we can separate out the 3/75ths. And that's what we're really doing, is we're multiplying t by 3/75ths. Let's see if they do anything else to it here. Oh, okay, so 3/75ths will reduce. Okay, that should reduce to 1/25th. Okay, so they'll end up doing that. They'll make that 1 mk y squared radical n. So essentially what we're saying is, because that was what I originally started with, is that t is multiplied by 1/25th. And I would accept either of these answers. We could say t is multiplied, t times 1/25th. Sorry. Or t is divided by 25. I'm putting that in shorthand, but that's how they're writing it, is t is divided by 25 or multiplied by 1/25th. I'd accept either of those two answers. Again, probably not one I would do, but it's not super hard if you understand it. Okay, 6. Okay, 6. What's that?
What?
Did you say something?
No.
Oh, okay.
What was it? 6.
Oh, okay. 6 is one that you wanted to see. All right, we've got 2 cis 84. Help me out here so I don't have to run back and forth. What's the other one? Negative 3 cis 66. Okay, and there's nothing else there. What else are we reading? Express your answer in rectangular coordinates. Give an exact answer. Whenever they say give an exact answer, they mean in radical form, so not decimal, okay, where I can avoid it. All right, so 2 times negative 3 is negative 6. And we've got 84 plus 66. What's that coming out to? 150. Okay. All right, so at 150 degrees, we're here just shy. Okay, but this is negative 6, right? What we should want out of this is this guy right here to get to positive 6. Okay, and we're just wanting the rectangular coordinates, so I'm not actually concerned with where this line is in reality. But 30, the side opposite of 30 would be 3, right? And the side opposite of 60 would be 3 radical 3. But I do need to remember that negative. Remember that when we're writing rectangular coordinates, what comes first, x or y? X. So 3 radical 3 minus 3i. Let's check our answer. 3 radical 3 minus 3i. Okay?
Anyone else having like a unresponsive page?
Maybe just refresh it. Okay. Haley, that was your question, right? Did that make sense? My guess is that maybe the part that you got wrong was not flipping it over.
Subtracted 150.
Subtracted 150 from. Oh, okay. So, and I'll try to send this document out whenever it's all completed and done, so you can go back and look at it as well as the video. Okay. The video will probably be in 2 parts. Okay. So, if you look at it and you write it down, you may not know exactly why certain things were done the way that they were. All right, go back and listen to the explanation. All right, what about number 7? Okay, number 7. How many distinguishable ways can 4 identical green marbles and 3 identical red marbles be arranged in a line? Let's see, because you have 7 marbles, right? All right. 7 marbles would normally look like that, except I have to divide it by 4 and 3 factorial. And then you make sure to keep all of that inside a set of parentheses whenever I actually do that in my calculator. Either that or I'm going to work it out pencil paper where I'm going to show 7 factorial and I'm going to find out what 4 factorial times 3 factorial is. Yeah, you should get 35 for an answer on that. Okay? Is that enough information there to get you to it? Is that what you got? Okay. Hey, Marcus. It's like tapping shows up as a huge pet peeve of mine, so I appreciate it. But do you need your Chromebook or anything open so you can actually see some of these questions, or is it dead?
It's supposed to be dead.
Well, we've got a charger here. Why don't you charge it? Okay, I don't want you missing anything if you don't have to. Number 8. Question number 8.
Yeah.
Okay. Jerry can do 3 jobs in 5 hours. When Brian helps, together they manage to do 65 jobs in 25 hours. How long would it take Brian to do 1 job? This is a good question. I might struggle to do this. Let's see. It looks like this is going to be a rate times time plus rate times time equals jobs because we're dealing with 2 people. So, okay, so let's start with that. We're starting off with Jeremy. Let's see. So we'd be looking at probably jobs per hour. So let's start off with 3 jobs in what, 5 hours? 5 hours. Okay. When Brian helps, okay, Jeremy can do 3 jobs in 5 hours. When Brian helps, they manage to do 65 jobs in 25 hours. I'm going to flip over because, let's see. Okay, so, all right, so this is kind of interesting. So we know that they work for 25 hours, right? We know the time. We do not know Brian's rate, but we do know that he also worked for 25 hours. And how many jobs did they get done? 65? 65. Okay. So let's take, 3 times 25 is 75. 75 divided by 5 is what? 15. So we got 15 plus 25R. Essentially what we have to do is we have to solve for Brian's rate. Okay, equals 65. We're going to subtract 15 from 65. Okay, which is what, 50? 50, okay. Okay, we're going to divide by 25. Okay, his rate is 2 jobs, 1 hour. Okay, well, hold on. Are we done yet? How long would it take Brian to do 1 job? Okay, this is 2 jobs in 1 hour, so, right, it would take him half an hour. So that's why we're getting, That's why half an hour is the answer. Okay, so be careful with that. I mean, just because you solved for his rate doesn't mean you answered the final question. Okay? But that is a good one. Number 9. Okay. Graph the ellipse. So it's what? X squared over 16 plus y squared over 1 equals 1. This is so easy it hurts. Okay? But I think it's just that you've forgotten, because I mean, we went over it so quickly because the easy stuff we fly through, right? And then you end up missing it. So there is a process here which I'm going to explain. Okay? So if I want to solve for the x coordinates, I'm going to set y equal to 0. So 0 over 1 equals 1. 0 divided by 1 is 0, right? So I'm getting x squared over 16 equals 1. I multiply by 16. X squared equals 16. Square root, x equals, because I'm square rooting both sides, positive and negative 4. Go ahead.
Oh, you multiply by 16.
Yeah, I multiplied by 16 here and here. Okay? Does that make sense on the x side? Now, if you want to know your y coordinates, you do the same thing, but with the other side. So 0 squared over 16 plus y squared over 1 equals 1. That cancels out. Okay? So I get y squared over 1 equals 1. Multiply by 1 on both sides. Y squared equals 1, right? Square root. And so I get y equals positive and negative 1 because the square root of 1 is 1. So what I end up doing here is plotting those points. So my x coordinates are both positive and negative 4, here and here. My y coordinates are positive and negative 1, and then that's my picture. Now, the fast way to do this is to understand that this is going to be the process, and I'm going to find the positive and negative square root of this denominator for x, positive and negative square root of that denominator for y, and graph those. I'm telling you that based upon what I'm seeing on your test question, yes.
So we don't have to do the process.
You don't even have to do the process, right? Because it's going to be the same process every time. Okay? They might complicate it in future lessons, but for tomorrow, don't overcomplicate it. Okay? So ultimately what they're going to be looking for are the positive and negative. What I'm going to be looking for is the positive and negative x values, positive and negative y values, and the graph. Okay? With tick marks and the whole shebang. Okay? All right. Number 10. Okay. Number 10. We have not skipped a single one. All right. Sine theta plus 2 sine squared theta equals 1. Okay. Sine theta plus 2 sine squared theta equals 1. Okay? One of the things I would probably do with this is factor out a sine. I think I can do that. That's going to be 1 plus, what, 2 sine theta? Problem here is that, let me double check because I'm thinking that 1 on the end might be an issue for us. We have to subtract the 1 first. Sorry about that. Okay, so we've got sine theta plus 2 sine squared theta minus 1 equals 0. I'm going to rewrite this so that we're seeing it kind of in order. I would call this 2x squared plus x minus 1 equals 0. Okay? And then factor that down. Let's see what we're probably looking at in a situation like that is 2x and x. The only real way to get, let's see, probably positive 1, negative 1, because 2 times x, or 2x times x is 2x squared. Okay, 2x times 1 is 2x. Okay, minus 1x is still positive x. Negative 1 times positive 1 is negative 1. Does that work? We understand that? Okay, so now I'm going to go back through and I'm going to sub in. So we're getting 2 sine theta minus 1 equals 0. Okay, and let's try to solve this out. Okay? We would add 1 and divide by 2. So sine theta actually equals 1/2. With me so far? Okay. So if we wanted to look at this guy, let's see, that's opposite over hypotenuse. So 1, 2, radical 3. This is going to be 30 degrees. Okay, so 30. Okay, we'd also get over here. Okay, 1, 2, negative radical 3. So where this would be 150. Okay, and looking through, they have it in degrees, so I'm thinking 30 and 150 because there's nothing else to do with this. My answers for this are 30 degrees and 150 degrees. And I can call that one done. Now, I do need to do sine theta plus 1. So that's going to come out to sine theta equals negative 1, which would be negative 1 over 1. Okay. Let's see. Negative 1 over 1, that's going to be 45 degrees here. We would have, actually, would not be there because that would be both. Should be here. Negative 1, 1. Okay, radical 2. 45 degrees here. So the degrees at which these occur are, what, 135? Did I mess something up? Oh, you're right. Major brain fart. Yeah, so because it's sine equals negative 1, you're absolutely right. You are. Yeah. So, yeah, we get 270 degrees there. Okay, let's take a quick look. Which was this? 30, 150, and 270. Yep. All right, that is probably about as much time as we've got, which is fine because we covered half of them. I'll get the other half covered in the other class. Okay? And hopefully the video works for this better than it worked for the geometry stuff.